Alright, welcome. We're going to talk about lesson 2.3 where we're talking about the product and quotient rules for finding derivatives, and we're going to look at higher order derivatives. So actually we're going to lead into the very first thing we're going to talk about. It's going to be a theorem. This is theorem 2.7 where we're going to talk about the product rule. So the product rule says the product of two differentiable functions, which we'll just call f and g, is itself differentiable. Moreover, the derivative of f times g is f times g prime plus g times f prime. So let's look at an example of how we would use this. So our first example, example 1, we're going to have the function f of x is equal to 3x minus 2x squared. We're going to have g of x, which is 5 plus 4x, and h of x, which is just going to be f times g. We want to find h prime. So, based off of our product rule theorem 2.7, h prime is going to have to be f times g prime plus g times f prime. So let's just go and find the derivatives of f of x and g of x. Let's find f prime and g prime. So f of x is 3x minus 2x squared. We've got a difference rule here and a power rule. So if we're finding f prime, let's first find the derivative of the first term. The derivative of 3x is just 3. We'll bring that minus through. Now let's find the derivative of the second term. We've got 2x squared. Well, if we bring the squared down, the 2 from that power down, we're going to have 2 times 2, which is 4x, and we have to reduce the power by 1. So 3 minus 4x is going to be f prime. Let's also find g prime while we're at it. G prime. We've got 5 plus 4x is g of x. We've got a lot of different things going on here. We've got a sum. So if we first find the derivative of the first term, 5, that's 0. So we don't have to write anything. The derivative of the second term, 4x, that's just going to be 4. So now let's try to find h prime. We're just going to take and substitute in the things we now know. H prime is going to be f of x, which is 3x minus 2x squared, times g prime, which is 4, plus g, which we know is 5 plus 4x, times f prime, which we found is 3 minus 4x. Alright, well, let's clean it up. Let's, in this first half of our derivative, distribute the 4. So we're going to end up with a 12x minus 8x squared plus, we can FOIL that last half. We'll go 5 times 3 is 15 5 times negative 4x is minus 20x. 4x times 3 is plus 12x. And 4x times negative 4x is minus 16x squared. Now let's clean some stuff up. Let's see what we have in common. We have a 12x, a minus 20, and another 12x. Well, if we add all those up, 12x and 12x is 24x, minus 20x, we're going to get 4x. We also have some x squared terms, a minus 8x and a minus 16x squared. Well, combine those, we're going to get negative 24x squared plus our 4x. And then I only see the one constant term. I only see the 115, so we can add a 15 at the end. We've combined all of our like terms. I don't see anything else we can do, so we've found h prime. H prime is going to be negative 24x squared plus 4x plus 15. Let's look at another example. So example 2. We're going to have y equals 3x squared sine x. We want to find y prime. Now this is going to use the product rule because we can separate this. We have y equals 3x squared times sine x, which means we can kind of just say f of x is going to be like our 3x squared and g of x is like our sine x. So if we were finding f prime, 3x squared, the derivative of that is just going to be bring the 2 down. We've got 6x. And from our last lesson, g prime, if a function is sine of x, the derivative of sine is just cosine. And based off of the product rule, the theorem 2.7, y prime is going to equal f times g prime plus g times f prime. So let's just plug in what we've got. Well, f, we're going to call that 3x squared. G prime we know is cosine x. Plus g we know is sine x. Times f prime is 6x. So now let's just clean it up. We're going to have 3x squared cosine x plus 6x sine x. And we could be done here. This is perfectly acceptable. If, however, you do notice the two terms have something in common, you could also factor it out. They do happen to have a 3 and an x in common, so let's just try factoring that out. We'll bring out a 3x. What we're left with inside, in that first term, if we divided everything by 3x, we'll have an x cosine x, plus if we divide that second term by 3x, we have 2 sine x left. I would take either of those as acceptable answers to finding this derivative. Let's look at another example. So example 3. We're going to have y equals 2x cosine x minus 2 sine x. We have a lot going on in here, so I'm going to break it up because we need to find y prime. We have a difference going on here, so we're going to break it up into two parts. The first part and second part. So let's just start by finding the derivative of the first part, the part I underlined in green. We could say 2x is our f of x, and cosine is our g of x. So from our product rule, we have to go f of x times g prime plus g times f prime. So let's do that. We're going to have y prime equals, in green, we're going to have f of x is 2x. Based off of our last lesson, the derivative of cosine is negative sine. So we've got our f times g prime. Now we have to do our g, cosine x, times f prime. And f prime is going to be 2. Minus, and we're going to just bring that next part through. We're going to find its derivative as well. Let's do it. We've got here a constant multiple and a trig derivative. So the constant multiple, we're just going to be bringing the 2 through. But the derivative of sine is going to be cosine. So we're going to have 2 cosine x. Now let's clean up what we've got here. 2x times negative sine x, we can call that negative 2x sine x. Plus cosine x times 2, we'll just call that 2 cosine x. Minus, we don't really have to clean up that last bit, 2 cosine x. Now I do notice something here. We have a positive 2 cosine x and a minus. Those are actually going to cancel each other out. So we've actually cleaned it all up. Y prime is going to be negative 2x sine x. Alright, let's move on. So we've seen a lot, or at least enough, product rule stuff. Let's now talk about the quotient rule. So we're going to look at theorem 2.8, the quotient rule. Now the quotient rule states that the quotient f divided by g of two differentiable functions f and g is itself differentiable at all values of x for which g does not equal 0. And I'm going to go and put the slash through the equal sign after I finish typing. Moreover, the derivative of f divided by g is given by, so I'm going to have to type this out, but first I'm going to put in our don't equal line. So the derivative is going to be g times f prime minus f times g prime over g squared, and g cannot equal 0. There's a proof for this in your textbook. I'm not going to go over that. Let's just look at some examples of how we actually use it. So let's look at example 4. We're going to have y equals 5x minus 2 over x squared plus 1. What we can do here is we can just say let the numerator be f of x, and we'll let our denominator be g of x. So if we let those be f of x and g of x, we can find f prime by just taking the derivative of the numerator. F prime is going to be 5. If we took the derivative of 5x minus 2, we'd get 5. G prime, we're going to take the derivative of x squared plus 1. We're going to get 2x. So now we can use that formula from theorem 2.8, where the derivative of y, when we're finding y prime, it's going to be g times f prime. We know g is x squared plus 1, so we're going to go x squared plus 1 times f prime is 5 plus, not plus, minus, excuse me, f, which we know is 5x minus 2 times g prime, which we know is 2x. We put all of that over g squared. So we're going to have x squared plus 1 squared. So now let's clean things up. If we look simply just in the numerator for now, we can distribute this 5 to the x squared minus 1. We're going to end up with 5x squared plus 5 minus, now we can also distribute this 2x to 5x minus 2. So we're going to have minus the quantity 10x squared minus 4x, but we are going to have to also distribute the minus to the 10x squared minus 4x. But before I do that, I'm just going to write our x squared plus 1 quantity squared in our numerator. So we're going to have in our numerator now 5x squared plus 5, and if we distribute the minus, we're going to have minus 10x squared plus 4x. And that's all over x squared plus 1 squared. And we'll take care of the denominator once we clean the numerator up. So when I look at our numerator, I see I've got two terms I can combine. I've got a 5x squared and a minus 10x squared. So let's combine them. We're going to get a negative 5x squared, and I only see the one term that has a single x up top, so plus 4x, and I only see one constant term, plus 5. All over, now you could leave the denominator as x squared plus 1 quantity squared, and I am perfectly fine with that. If you don't want to do that, you could multiply it out. So you could also get negative 5x squared, oh, and I forgot to write in x after my 4, plus 4x plus 5 all over, we could use our algebra sheet I gave you in class. We'd have an x to the 4th plus 2x squared plus 1. I would take either of these answers. Alright, let's wrap this video up actually, and our next example will be in our next video.